All right, hello everybody, and welcome to another episode of React Wednesdays. We've got a fun crew here today to talk about Hermes, which I'm pretty excited about. So first of all, on our panel today, we've got, as always, Dan Wilson.
Hey, I'm Dan Wilson. I work with Digital Primates. We do enterprise React consulting. We also curate the enterprise React newsletter. So if that's your kind of thing, Google it, sign up. We never sell your email address or spam.
Awesome. We also have Christian Pillsbury, correct?
That is correct, like the doughboy. Also, Digital Primates employee. I'm a senior engineer consultant over there, working on the same sort of stuff, enterprise React, that kind of stuff.
Awesome. And then we also have an awesome group of people from the Hermes team itself. So I'm going to take you in the order you pop up on my screen. So first of all, Saphal Patro.
Yeah, that's correct. I don't know. A lot of people get that wrong, but yeah, you are correct. That's awesome.
Wow,
so
TJ, 10 points.
Yeah.
I'm not actually in the Hermes team as such, but yeah, I worked with Ram and Neil in the MLH fellowship. I just worked with them on one of these projects that we had, which was the Hermes profile transformer. More on that later, of course. And yeah, I don't have any fancy things going on, but yeah, that's pretty much it for me.
Awesome. And then also Neil Dar.
Yep. Hi. So my name's Neil. I'm a software engineer on the Hermes team at Facebook.
And Jessie.
Hi everyone. I'm Jessie. I'm a third-year computer science student at University of Rochester. Yeah, I work with my teammate Saphal at the MLH Fellowship. I'm really glad to be here today.
And also Ram as well.
Hey everyone, my name is Ram and I'm an engineering manager in Oculus at Facebook. The reason why I'm involved with React Native is because before this, I was in the React Native team working on performance and the new architecture of React Native. These days, I'm trying to go beyond the phone apps to develop user interfaces on virtual reality, and that's what has got me into Oculus. You'd be surprised, but we are also using React and React Native quite a bit in the VR world, and that's the part that I'm working on.
Your resume and bio is way cooler than mine, so that's very, very exciting.
Well, we have a running gag here on the show where TJ tries to pronounce people's names, and it's usually quite funny. But I think you got 6 for 6 today. So
well, I didn't try Ram's the rest of his name. I didn't attempt that. So.
Also, for what it's worth, Ram is not my real name. It's much longer. I do not want to subject you to that.
Well, very cool. So our topic today is Hermes, which is something I'm super excited about. So if you have any questions on the chat that you want to bring up, feel free to drop them in and I'll present them to our group of people here today. But Neil, I know you were going to help set the stage for us in terms of just what is Hermes, what is it doing, and why do we care about any of this? So you want to take it from here?
Yeah. So Hermes is really so Hermes is a JavaScript engine. It essentially executes JavaScript, and what makes Hermes unique is that it's optimized for mobile environments, and specifically, it's optimized to make React Native go fast. So at Hermes, we work on trying to make React Native applications more interactive, make them launch faster, and those are really subject to a few different constraints that you'll see on mobile devices. So one, you have less memory than you would have on, say, a desktop. You have less storage space, and you have pretty high I/O latency. So it takes some time to communicate with the storage that you have. So before going any further, let me just show a video of Hermes compared to what we used to have with on React Native before. And this is just showing an app called Mattermost, which is a React Native app being started up. And you can see that on the left side with Hermes, it starts up significantly faster than it does on the right with what we used to have. And so this just shows sort of how Hermes can improve the interactivity of React Native apps. And in fact, on a sample application, we were able to see some pretty significant improvements where the time to actually get the app interactive, so that the time before the user can put in their first input, improves by almost 50%. The application size also reduces by about 50%, and memory usage decreases by about 30%. So Hermes can really bring some pretty significant performance wins and interactivity improvements to React Native applications.
Yeah, these numbers are interesting, especially considering that there's a lot of lower powered Android devices out there, and the file size and the memory utilization, they can be very, very important in many regions of the world.
Right. And that's really what we're targeting. We're trying to make sure that Android devices, across the entire distribution of their hardware capabilities, are able to use React Native apps in a useful way, because people still want their apps to be interactive regardless of what device they're using.
Now, you said in terms of what it used to use. So React Native, the graphic, you had Hermes on one side. Is it V8 on the other? Correct.
I believe it's JSC. So
it's JSC.
JavaScript core. Yeah.
Okay. And is that the default? Like if I file new React Native app by default, do I get Hermes today or do I get JSC?
I believe you get JSC, but I'd let Ram confirm.
Yes, that is correct. So when you say React Native init, you do get JSC on both iOS and Android. And then on Android, there's a specific graded file. It's kind of well documented in the React Native website, but if you go change the graded file and say use Hermes is true and then clean build it, it'll start building up with Hermes. In fact, replacing the JavaScript engine is actually that simple. All you have to do is just change that single line and you should be able to get up and running with Hermes.
When did this project start? And is it considered like, I'd be curious in terms of when, is there a path for it being the default or anything holding it back from that right now?
So I know that, so the project started about 3 or 4 years ago, I believe, and sort of with the intention of making React Native apps at Facebook go faster. I don't know if there's currently what the status is on making it the default experience in React Native.
So there are still a few parts where, so as far as React Native is concerned, I think one of our biggest goals is to ensure that we are backward compatible. We do not want to break people and existing applications. There are still some features in the open source, like some plugins and view managers and native modules in open source that aren't compatible. Some of them use like very obscure ES6 features and stuff. So swapping it by default kind of will make it harder for those applications. And given that switching is actually so simple, we thought that we should just live with JSC for now. And eventually when the community is able to like upgrade all of their code, we should be able to move to Hermes as the default. I think there are a lot of applications out there who are already starting to use Hermes and have seen significant performance wins.
You mentioned there was some esoteric EX or ES6 usage. Can you sort of walk us through what a developer might want to be aware of in their app to indicate that Hermes might not be the best choice for right now?
I don't have a full list of ES6 features. Neil, do you remember on the Hermes side some of the ES6 features that may not have been implemented yet?
I'm not totally sure, but yeah, what might be being used outside in React Native that we don't currently support.
I think there was a time when like proxies were not supported, and it's also kind of hard to remember these because Hermes is making changes, and with every release we are adding more and more ES6 features. So I don't have like a spreadsheet that tracks all of these. But what I can say is the best way for a developer to try it out is just switch over to Hermes because it's a simple switch. Switch over to Hermes, see if it works, and if all of their test cases kind of pass, you should be good to go and start using Hermes. That's probably the easiest migration path that I can think of.
So these would be hard failures then?
Yes, that is correct. These will be hard JavaScript failures. It'll basically say, hey, it'll actually show up the red box saying this function is undefined or this doesn't work out.
Okay, well, that helps. Sweet.
Are you all using any of the like open community, like the W3C test suites for confirmation on ECMA compliance, stuff like that?
So we do have a bunch of open source test suites that we run Hermes against in order to make sure that we're largely compliant with ECMAScript standards. I believe so. Yeah, we're mostly compliant with ES6. There are still some features that we don't support, and yeah.
Are you ES6 or ES Next? Like, do you support nullish, no coalescent, stuff like that? Any of the new stuff?
I'm not sure.
Okay, no worries.
Yeah.
And actually, as a broader question, so my first sense, when I remember first hearing of Hermes, is like this sounds like it would be a massive engineering uptake because like JavaScript engines are not simple, right? Like it's no small thing to go like, oh, let's build a new JavaScript engine. That sounds like a fun thing to do today. So is it like a fully featured JavaScript engine? And like, is there a potential where like a browser could use Hermes, or like Node could use Hermes, or like, is it really like carefully crafted for React Native, or does it have that sort of general JavaScript execution potential?
Yeah, so Hermes targets, you know, the ES6 standard, and so it could be used for server-side execution environments or in browsers, but it's not. That's not what it's designed for. It's really designed to be fast on mobile devices, and there are architectural decisions that we've made that make Hermes very fast on mobile devices, but not necessarily the right choice on you know, when you have much more powerful hardware.
Could you provide like maybe one specific, like what, I guess, like what makes Hermes so fast? Like what would you have to take out of like V8 or JSC to make it faster? What's slowing those engines down on those platforms?
Right. Yeah. So I have a picture for that. I have a slide. Let me.
Way to tee it up.
I queued you up, man. Oh man, next slide even.
That was a planted question. Wow. So typically in most JavaScript engines, you'll ship minified JavaScript together with your application. And so you'll take the JavaScript source, you'll minify it, and then you'll ship that in your application. And then at runtime, when the user loads that application, the JavaScript engine will go through the entire program. It'll find each function. It'll make sure that the program is like sort of lexically correct. It has parentheses in the right places, and you closed every brace. And then it'll take all of that information, and it'll construct an in-memory representation of the program. And so you've already taken this JavaScript and you've created this in-memory representation. So that's consuming some memory. And then it'll compile this function into some bytecode and then execute that bytecode. And so this in itself is already a significant portion of your startup time. Mm-hmm. And then in addition to that, as it's executing that bytecode, it'll start to identify functions that are executed over and over again. And it'll start to compile them down into native code using something called a JIT, or just-in-time compiler. And then over time, as it sees functions are called even more, it'll start to optimize that native code that's compiled further and further until you have extremely fast native code. And so over an extended period of time, this generates extremely efficient native code for your device. And so you can run JavaScript very, very quickly. The difference in Hermes is that we actually try to move a lot of these steps into build time. And so what we do is we take the JavaScript source, we compile it, and then we optimize it beforehand. So as you're developing, you'll optimize your application on your development machine, which is very powerful. And so we can take our time and do all of the optimizations. And then we generate bytecode from that. And then we take that optimized bytecode and we ship that with the application. And so that optimized bytecode is smaller, and it also saves you all of these steps that you had to do at runtime earlier, right? And so previously, where you had to actually parse this entire JavaScript file and then generate the bytecode at runtime, Hermes just ships the bytecode with the application. And so the user program never has to actually run through the entire program, make sure that it's correct JavaScript, and then start loading it and generating the bytecode and executing it. At runtime, all we have to do is load in the bytecode from disk, which is just going to be a file, and we just start executing it line by line.
Does this mean you need a special build tool to build it in a way that Hermes can understand it at runner, interpret time?
Yeah, so Hermes is also a compiler. So Hermes will compile this down into the bytecode. And then you can just use that bytecode that's generated by Hermes to execute the program at runtime.
So it sounds like, yeah, go ahead.
I'd also wanted to add here that this idea of bytecode is actually not something that's like unique to Hermes. In fact, V8 also does this, and this is also something that's, not really snapshots, but bytecodes themselves. And in fact, also on the JSC side, Tadao Zagallo, who used to be on the React Native team and is now at Apple, implemented a similar functionality for JSC. So this is actually a technique that many JavaScript engines are using today to speed up like how they're interpreting and executing bytecode.
Yeah, it makes total sense. One of the things I wondered is if you dynamically loaded JavaScript at runtime, would this process be a problem, or would there be a way for Hermes to sort of handle this new introduction of JavaScript that wasn't provided at compile time?
I mean, a common example of that would be something like just a simple fetch from a REST API. You have some JSON, you do a .parse, and you start using it in your code. That's going to be common. Yeah, so maybe just explain what happens in that kind of scenario would be a good walkthrough on that.
Right. So Hermes can also execute JavaScript directly. So if you want to introduce additional JavaScript into a running application, you can do that because Hermes can execute both bytecode and JavaScript. And it'll just take that JavaScript and then compile it down to bytecode and execute it.
Gotcha. So the innovation here is you've provided a way at build time to do all of these steps that you can do, but they're not mandatory if you need runtime execution.
That's right.
Fair enough.
Also for what it's worth, runtime execution can also happen in Hermes. Like you can actually load dynamic Hermes bytecode and load it. So you can either load the Hermes bytecode or JavaScript, like plain ASCII JavaScript code, and both of them can be done at runtime and compiler, like at startup or like eventually during the lifetime of the application.
How is the performance? Do you all have any metrics on like if you have a network heavy application that gets a lot of JSON, for example, and you're having to parse that frequently? How does that compare to some of the beefier JITs out there in terms of performance?
I don't have any metrics, but I would suspect that if you're running the same function over and over again, the JIT would benefit from that, and the JIT would be able to compile those down. But what we found in testing is that certainly when you're starting up an application, React Native runs most functions one time, maybe. And so there's no real benefit to having a JIT in that case. And even as you're running the application, the JIT doesn't necessarily add something that improves interactivity perceptibly. So you may not be able to notice that the JIT doesn't actually add that much to interactivity specifically.
Now,
I think I can also validate that from the app perspective. So one of the apps that my team is working on is the companion app for the Oculus headset. That is completely written in React Native, and I think the kind of data that we get back does indicate that there aren't many functions that are in the hot loop. What actually more frequently happens is that one, we want to be able to start up and wind down the JavaScript engine as fast as we can. And secondly, like the kind of responses that we get is usually not the same. Like we don't get the same kind of responses over and over again. And that's probably why like Hermes is kind of the right choice for mobile applications in the mobile side of the world.
Are you all, is there anything, I saw in the architecture blog post you guys have that you said there's no JIT yet, kind of like a parenthetical. Are you all thinking about longer term going the more modern JRE routes where you have bytecode and then based on optimizations in the environment, you might do a JIT of the bytecode sort of scenario? In particular, I'm thinking about this because JavaScript is very Wild West with its object structures. So optimizing, if you don't know enough information unless the app has been running for a while to know how to fully optimize within an environment, I would think. But you guys probably know better than me in terms of that. So yeah, any thoughts on like forward looking for that kind of stuff?
That isn't something that we're working on right now because we just don't see that it would necessarily improve the performance of apps. But that's certainly something that we keep in mind.
Cool.
TJ.
Man, I do this all the time. Put myself on mute. Question came up from chat. Do you need to know the specific architectures of your app when you run it build time? Like, is there a specific, do you have to say like, I'm building this for React Native or for whatever? Is it just sort of a general build?
So the bytecode is portable. So the bytecode will run on any architecture. And Hermes doesn't need to know what. So as long as you have a Hermes binary on both devices, if you compile it on one device and you run it on a different device, it should work fine.
There was something I remember where you could split up an APK file into different architectures and ship them, although that wasn't the official Google way, and which indicates that there was some kind of process to build for different either CPUs or some sort of low-level componentry. Is that something that you support as well?
Yeah, so Hermes itself, the Hermes binary will have to be built for different CPU architectures. But the bytecode is portable. So if you can compile Hermes for say ARM32 and ARM64, and you'd ship Hermes. The Hermes binary would be different, but the bytecode would be the same, and you'd be able to run that on either device.
Got it.
I know we have some other demos we wanted to show today, Saphal and Jessie. I know, so maybe we could segue into one of those. I don't know which of you were planning on going first. Any volunteers?
So let me actually tee up the demos, and then I think like Jessie can talk about the demo itself. So what we've been looking at is like, if you notice, one of the big things we've been talking about as soon as we spoke about Hermes is performance and speeding things up. So while Hermes does speed up things, I think it's important to be able to measure it and actually indicate that, hey, something is fast or not. There are multiple ways to do that in React Native. You can actually profile React Native applications to see how long a JavaScript function took. You can, and because React Native is both native and JavaScript, you can profile both sides of the story. Now, after you've profiled it, you might discover that there might be some issues in React Native where some of your functions are slower than the others. And what you would want to do at that point is try to profile JavaScript specifically to identify such functions. And typically, when you do that on the web, you use something like a JavaScript sampling profiler. And the demo that we have today is to show up a similar sampling profiler for Hermes. Now, this is a project that Saphal and Jessie worked on. This was a part of a program called the MLH Fellowship Program, where the React Native community, the React Native core team engages with community to onboard students to help them contribute to open source. So the MLH, the Major League Hacking Company, they partnered with GitHub and Facebook to come up with this program. And as a part of that program, Jessie and Saphal were allocated to this team. I think Jessie and Saphal can talk a little bit more about the program. But this was our attempt to help more people on board and like help people get started with open source. Jessie and Saphal, over to you.
Yeah, I think we'll start with Saphal sharing his screen, and we'll talk about like our experience doing this project, and how did we start with. Yeah.
Yep, and we should be seeing your screen now, so you should be good to go.
Yes. So I want to talk about trace events first. So when we enable sampling, the program will create trace events. And in terms of Hermes profile, this profiler will have a JSON object format, which is different from the Chrome tracing event, which has the JSON array format. So for the Hermes profile, we have three key value pairs: trace events, samples, and stack frames. And the samples and stack frames are actually those that contain the most information about which functions they're running and like their timestamps and stuff. So Saphal, can you expand the samples? Yes, so as you can see here, each sample will have an SF field, which is like an ID to mark that stack frame, and also like a timestamp. And if you look at the stack frames, these are actually giving more information on the SF ID that we saw earlier. It has information such as the name of the function, the category is in, whether it's native code or JavaScript or like a node module. And also it gives the parent of that stack frame. So it's you can see here that 5 has a parent of 4. And 4, 3, and 3 has a parent of 2. So it's basically like a tree structure, co-recursively, you know, which function happens first and which happens later. Yeah, and also another thing I want to talk about is, so the trace events have a lot of types, but in Hermes, we just have duration events, which has 2 phases, the start and the end phases. And yeah, so but basically for Hermes profile, we deal with those type of events. And I think Saphal can explain, so how do we do our project with these in mind?
Saphal, I think you're on mute.
Saphal, you're muted.
I'm also curious, is this something that,
Yes.
just to set the context a little bit, is this something that Hermes outputs as it runs? Is that what we're looking at, the like .cpu profile file?
That is correct. I think the way it works is on React Native, there's a way to start and stop profiling of Hermes. So what you typically do is, let's say you're running a profile, you're running a scenario where clicking on a button kind of slows it down. And you want to investigate why is clicking a button like stopping an animation or causing jittery animations or something like that. So what you would typically do is you'd start the profiler, then run through your scenario, which is like clicking a button, letting the animation run, and then stop the profiler. And in that time frame, what you get is the output that was just showed, and you would then start using these outputs to these profiles to figure out like what was going on.
Okay, perfect. Thank you.
Also, yeah, we took the terrible bad decision of showing you how to profile after we explain, which is a complete mistake. But yeah, we're definitely going to get to that as soon as we just finish up on a little bit of context. Yeah. So so I just want to introduce the term nodes, which is what we used which was like a recurring term throughout our project. So like Jessie said, events we can essentially call events like functions, right? Like let's say a function named A is running when we are running the app, right? So we can call A is an event, right? And the A event can have two phases, that is, can have essentially three states. That is, it either starts or it's running or it has ended, right? So now all we have the information in samples and stack frames is that, oh yeah, an event started at this point of time, these functions are running, right? Because so we had, like Jessie said, that each sample had a SF property, right? Which essentially points to a function. And then we can recursively travel up and see that, oh yeah, these functions are running at a particular point in time. So to generate like start nodes, the events that start at this particular point and the events that end at a particular point and the events that are continuously running throughout these two particular timestamps, we introduce the term of nodes, which is just an event in a particular phase, right? So to get start nodes, I think this Venn diagram is kind of making it very easy that, oh yeah, if the nodes at the current timestamp and the nodes at the previous timestamp can be used to get this, like let's say a node is running in the current timestamp, but it was not present in the previous timestamp when we sampled. We can just say that, oh yeah, this event started at this particular point in time, right? Similarly, if a function is present in the previous timestamp, not present in the current, we can say that that event has ended at this particular point in time. And stuff that's present at both the durations is just an event which is happening, right? Yeah, so I think I'm just gonna like profile a very simple, like just a simple JavaScript file which is just calculating Fibonacci number recursively, right? And just doing math.random because it seems like an expensive function. So I just wanted to simulate some functions, right? So yeah, so because as we all know, live demos are completely susceptible to, me screwing up. So I took the liberty of like just creating a bunch of profiles, right? Which is where I just calculate the Fibonacci of 25 and the Fibonacci of 30 with, like, let's say the math.random function, which is what is denoted by the F1, right, in the file. So yeah, so let's just use this Hermes profile transformer, which was our entire project, right? To see this profile in Chrome DevTools, right? So just extremely simple file. We just transform this by giving it the profile path, and I'm just stringifying it and saving it. Yeah. So let's generate our first one, which is for 25, and we can also generate the one for, let's say, this one. And yeah, so we have both these files. Now we can definitely open them in Chrome DevTools. By the way, I'm doing this live. I really hope nothing nothing is messed up, but let's see.
You're good. You're good.
Yeah. So yeah, so this is fib of 25, and you can see that there are all these different function calls, right? And we can also see like the line number and stuff, like, oh yeah, line 10 and column 15 is where this function is being called, and then this function is being called. And we can also see that because I did the extremely naive implementation of recursion where I go n-1 plus n-2, we can see that n-1 takes longer, n-2 takes comparatively lesser time. And yeah, so this is how we can like just like see the profile that we generated, right? And this is for the slightly more interesting variation where, we have that mat.random function, which just comes in at the end sometimes. Yeah. So yeah, this was essentially our project, because the samples and stack frames do not like straight away are displayed in this Chrome DevTools. So we needed this transformer kind of thing, which could, make sure that the format is compliant to something which can be seen on Chrome DevTools. So
and curious, is that like a open like standard? Is that something that Chrome put out? Like, is there like, who decides that format that you're outputting now?
Yeah, so I kind of saw that question coming, so I opened this document on the side.
Man, I'm knocking it out of the park today, man.
You're reading from the cue card.
Absolutely, yeah. I promise this is not scripted. Okay, he came up with it spontaneously. Yeah. So this is the trace event format, which is just dictating the two different formats that Jessie had talked about, right? So these are the JSON formats, like the JSON array format as well as the JSON object format. You can definitely refer to this document to get more details, but just to sum it up, most of the stuff which we can see in Chrome DevTools is usually in JSON array format, which is just simply just an array, and each of these is just an event, right, or a node that I said. And the stuff that we get from Hermes is the JSON object format, which has these three key value pairs, like we talked about: stack frames, samples, and trace events. So now what happens is it's just that the Hermes engine does the Hermes profile has more information in samples and stack frames, whereas for other stuff it's usually present in trace events. So we just needed a transformer to convert all the information that's present in sample and stack frames into something that can be seen on Chrome DevTools. So yeah, that was the idea.
And is this like a Google made document? Like who's actual, like who is the keeper of the trace event format? Like who oversees it?
I think it's Google, but I'm not sure. I think Ram has.
So this is definitely Google. This actually the profile format was actually something that was like native to Google, and Google does use. So if you look at the web browser, like if you open up the performance panel on the web browser for even for like profiling web pages, this is the format that it outputs. In fact, at the top you have like a up arrow and a down arrow, which is like save the profile and open it. So and when you do that for the web page, this is the exact format that is used. Yeah, those two arrows.
Yeah.
So then, is this? Do you know is our Firefox and Safari? Would this work with them, or do you have any idea if?
So Safari does not, and the interesting thing is Safari has its own format related to profiling. In fact, you can turn on sampling profiler on Safari also. So you can kind of get a similar information, not as rich though, on Safari when you with React Native when you're profiling it and when you're actually running it on iOS. And the format is definitely a little bit different. I haven't honestly tried Firefox, so I'm not sure what format do they save it in.
Gotcha. I mean, not that I'm not. I got to go this way. Like I'm a Firefox fan, so I have to ask, right?
Yeah. So I think Jessie can now go to the React Native stuff. So yeah, over to you, Jessie.
Yes. So I'm gonna share my screen right now.
Yep. You're good.
Can everyone see it? Yes, nice. So as Ram said, so I have my React Native app here, and I can open the developer menu and click on enable sampling profile, and similarly click on disable sampling profile. So that's how I'm going to obtain a profile. And also with the idea that live demo can be very susceptible to failures. It's not, I didn't prevent much, but so here you can see that this is the, so if I ADB shell to this, to this catcher folder in my Android device, you can see that there are a bunch of CPU profiles that are saved from that enable and disable sampling button. And I believe the most recent one is a nested function profile, CPU profile. And yes, so here I have the most recent code of the CLI. And what I will do is that I will run the command React Native profile Hermes that Saphal and I just worked on during the summer. So what this command does is that it's gonna access the Android device data and then pulling the CPU profile that we just like sampling profile from our React Native app. And in this case, the file is named nested function profile.cpu file, as we saw earlier. And what it does is that it converts this Hermes profile to Chrome tracing format and pull it into the local machine. So like the right directory that I'm at in my React Native app. And well, here I will open it in the Chrome DevTools where I already did. And you can see that this is the full profile display on Chrome of the React Native app that I had. It was a very simple app. It was like a button to count like 1, 2, 3. And here we can see that, for example, this function, we can look at the function line, function column of it, while taking into consideration the source map. So we map this information with the source map so that we have more correct insights into where this function is. So into the function line, function column, the name of the function, category, and yeah, that's it. The anonymous functions are those that don't have a definite name, but rather is like an HTTP URL link. And yeah, so that this is the final product of our project using the Hermes profile transformer.
Yeah, this is really cool. I think what I like about it is, I mean, I've been doing JavaScript for a long time, and I still find the performance pain not the world's easiest thing to use. But the thing is, like, because it's using a standard format, right? It's one of those things that I don't think there's a good way of totally visualizing performance data because it's sort of inherently a little bit tough to parse. So I like that it's using a format that people have already seen before, or at the very least, something you can go to YouTube and like Google and find somebody who's good at explaining it, right? And have the same thing apply to what you're doing with Hermes as well. So this is really cool.
Well, and on top of that, it's given that one of your primary goals was to do performance comparisons, you wanted a format that was available for the standard runtime for Android. So, obvious candidate right here is you can actually look at them and see the difference.
So the workflow, just so I can understand it one more time, basically on your device, there's a way like built into React Native, right? To actually start the profiling session, right?
Yes.
And then that saves it to, go ahead.
Yeah, no, yeah, I think you're right. And then it saves to the Android device.
Yep,
like
and then
here,
you're using the tool you wrote to actually pull it out of there. So then I think my next question would be, if other people want to do this, is like, how do they access that tool that you have? Is that something you have to install into your React Native project? Or like if I had a React Native Hello World app today and I wanted to do this too, what are the steps I have to take to actually enable this?
Yes. So you're talking about the command, right? React Native profile Hermes?
Yeah, like will this, if I start React Native like a brand new app, will this command work for me?
Yes. So this one has been merged to the most recent React Native CLI repo. Yeah, so it's part of the React Native CLI. I'm not sure if it's like been released yet, but it will surely come with the new version. Yeah, so
awesome.
This is part of the React Native CLI. Yes.
That's got to be pretty fun working on this project and getting your code shipped into something that, if not millions of people are using it. And you said you're a third-year university student, aren't you?
Yeah, I am.
Well, you've really made the most out of this opportunity. Congratulations.
Yeah, thank you. It was a very fun experience, especially working with Ram, Neil, and Saphal. Yeah.
Yeah, we got some comments from the chat as well. Yeah, my third year in university, I was building like the equivalent of GeoCity sites for the web, which did not contribute to the greater good of the software ecosystem. So definitely very well done.
When we shift topics, I want to dig in a little bit to this Major League Hacking organization and talk about the internship. But if this isn't the right time, let's continue where we're at.
We can do that. I'm actually curious as well. Like, if other people are interested in this, like, how did you get involved with this in the first place?
Yeah, so the MLH fellowship is it's just started this summer because of COVID. So a lot of students got the internships canceled. So they want to design a completely remote internship. And we started applying in May, right? So, and got our result in May too. So they worked really hard to go through the applications. Our start date was June 1st and end date was August 24th. So 12 weeks working on that. And we worked on the team size kind of varies. So for our project, it's just two of us, Saphal and me. And the projects comes from our sponsors, companies. So in our case, Facebook. Yeah, so we met Ram and Neil and just work with them, ask them questions every week on how we should move forward in the project. And yeah, I'm happy that it ended up well. So do you want to add something?
No.
Sorry, go ahead, Saphal.
Yeah, so me and Jessie, when we were a part of the team, we had this running gang that Jessie just explains stuff better. So yeah, I don't really have much to add except that the MLH fellowship is again just open. So if anybody in the chat is interested, they could definitely apply.
Is it mlh.io? Do I have the right link for this?
I think so. So it's fellowship.mlh.io.
Fellowship, okay.
Also, I did want to add that it might be interesting to talk about some of the other projects that were a part of the MLH fellowship. So this is one of the many pods. The other pods included things like the next generation of React profiler. This is something that Brian Wan on the React team helped mentor, and there were few people who built that. There was also a pod that rebuilt the React Native sample application from ground up so that people are able to learn React Native faster. There were a whole bunch of projects, and also this in the fellowship is happening again in the fall. And if folks are interested, they might be they might want to apply to this because this is a great opportunity if you are not able to do internships in person to actually connect with big companies and try to figure out how you can contribute to open source.
Yeah, and you get to also interact with folks like yourself, Ram, and you've been around quite a while and been involved in really lots of great stuff. And if I was Jessie or Saphal, I'd be most excited at getting to pick your brain for 12 weeks and adding you into my Rolodex.
Yeah, we were super psyched.
At this point, so we got about 15 minutes left. So I want to make sure while we're just chatting about Hermes, as we're talking here, if anybody has any questions in the chat about Hermes or any of these profiling projects or the MLH fellowship at all, feel free to drop in the chat. I know, Christian, did you have any questions that you wanted to pop by here? Because I want to make sure we have time to dig into any last things we want to cover.
I'll always nerd out on compilers from runtime.
All right, let's do it.
Yeah, so actually Digital Primates, our history was rich internet applications in the Flash and Flex runtime. So we've been doing some full stack stuff in the JRE. So we're pretty familiar with bytecode and doing crazy things with bytecode. Well, I guess one question would be, given that JavaScript, unlike other languages that I associate with bytecode compilation, is a little bit more of a Wild West scenario, are there any particular ways of writing code, I'll leave it that generic, that would be better optimized by your bytecode language, like using classes instead of loosey-goosey pojos, any little things like that you would have pointers for people who are trying to write Hermes optimized code?
Not per se. We do try to. So, for instance, we'll try to infer the structure of data structures as you write them. So, if you try to use the same shape of structure over and over again, Hermes can actually extract that structure at runtime and run sort of more optimized code paths based on that. So, yeah, writing normal idiomatic JavaScript is probably the way to go, and then we're always looking at how we can improve performance, especially with React
I'm also
Native.
hoping that people don't have to resort to writing Hermes specific or like V8 specific JavaScript code. Like I think it should definitely be the other way around, where like the JavaScript engines are the ones who are picking up what are the most common patterns and then using those to inform how things can be adopted and like made faster.
A lofty goal.
Yeah, yeah. Yeah, I guess kind of similarly, do you all have any long-term plans or anything, at least like seeds planted for things like WebAssembly? I saw you guys were able to target Wasm for a build, but are you planning on doing like Wasm optimized bytecode, anything like that? Okay.
I don't believe so.
Cool.
I don't think that's something that we're focusing on right now.
I'm curious, are there any plans to try to, like, are any people doing any interesting things with Hermes, considering it's an open source project, like beyond the React Native space? Like any interesting use cases? Like, does it have a play in Oculus, perhaps? Because I could see Oculus also potentially being like not quite as performant of an environment as, say, like a dedicated PC and such.
Smart TVs, other.
Oh yeah.
I think as far as Oculus is concerned, I'll probably have to stop with saying the answer yes, but I definitely want to go into details a little bit about like the other platforms that we're talking about. And I think this is also comes from the general principles of React, where we released a blog post of I think 1 year ago, where we said that we are looking at React as a platform and React Native as one of the ways to implement it. In fact, Hermes is actually being used by Microsoft for the React Native desktop side of the world. And Microsoft has actually been successful in compiling and using Hermes for their desktop application. This was something that they spoke about at a recent conference. And to them, like they've actually seen like performance gains when they were using it to build up their desktop application and moved away from Electron to something that was React Native based. The advantage there being you actually now don't have to use web views, but are using native UI constructs that are specific to desktop.
Yeah, we had them on last month to chat about that. Kiki from the Microsoft team was on, but I don't think Hermes came up. I think that's pretty interesting that they're using it on the desktop, because to roll this conversation back to the beginning, you optimize for low power devices, but a desktop is like the -1 of that. So I wonder if you can sort of dig in about why they might have made that choice.
Yeah, I guess so some of the benefits still apply on desktop. For instance, you'd be able to get that faster startup speed. We'd be able to be more memory efficient because it's optimized so heavily for mobile. Those benefits, Hermes is designed for a pretty resource constrained environment, and so those benefits will also translate somewhat to desktops. And so we'd be able to decrease the memory footprint of applications. We'd be able to start up the application faster. And so yeah, there would certainly be some benefits that translate over.
That's actually pretty great, because I have at least 2 gigs of memory being taken up by Google Chrome. And so if you could talk to those fine folks and see if they wouldn't mind forking Hermes and taking pity on my laptop here, I'd appreciate that.
Well, I am curious, like, do you see a potential future where Hermes found itself in places that are now more accustomed to being like V8 or JSE or some of these other JavaScript engines that are out there? Because even though like there are very few environments that wouldn't like to have performance gains, right? Like everybody would like to have those. So like, could you see Hermes being used in something like a browser, for example?
It certainly could. There's nothing technically stopping it, I believe. But I guess that's not where we're focused right now. Our focus right now is still entirely on React Native for Android.
Okay.
And improving performance there.
Have you guys been looking at like Tizen or because another resource constrained environment are things like smart TVs or like game console stuff potentially? Like, have you guys been exploring that? Because I've definitely fought against that. There's obviously going to be the pain points of you have to punch some holes through the runtime for all of the media source extension video stuff. But other than that, it seems like a really good candidate for something like Hermes.
So we've had some explorations with Netflix on this, but we haven't actually made any progress. I think, as Neil said, our biggest things that we are interested in is ensuring that React Native is top-notch and is performing best. So I think our focus is definitely very narrow in terms of React Native for now. While we are open to like working with community partners, I think from a Facebook perspective, we are heavily investing in React Native itself.
Is it possible that you could chat a little bit about the use of React and React Native in Oculus?
Sure. So the Oculus companion app is definitely written using React Native. That's a typical like React Native application that you'd see outside. Talking about React Native, I think I don't want to restrict it just to Oculus, but I probably should also talk about like the use of React Native inside Facebook, just to give you an idea of like how widespread Hermes is. So on the main Facebook app, the main Facebook app is like a hybrid app where you have like a lot of native components. We do use Litho and Component Kit, which are two Java/Objective-C frameworks, but there are a lot of pages in the main Facebook app that are written using React Native and are powered using Hermes. Some of these surfaces that we have spoken about publicly include things like Facebook Marketplace, which is like a super successful product and serves over like 800,000 users every month or much more than that. This was like statistics from last year, but there's like a lot of usage there. The new and improved Facebook dating is one of the areas that's inside the Facebook app. And apart from the Facebook app itself, there are a bunch of other standalone apps that Facebook has released, which are pretty much built on top of React Native and hence use Hermes heavily. This, as I said, includes the Oculus companion app, but it also includes the Portal companion app, the Ads Manager app, the Pages Manager app, and a whole bunch of internal applications. There are also parts of React Native inside Instagram. And I've also heard that certain parts of WhatsApp also use Instagram.
So it's got a lot of usage internally with internal apps.
Internally, we have actually seen the usage of React Native grow year over year. In fact, it's significantly increased over the last like 2 years. And that's just not React Native, but we're also thinking about like on the Oculus side of the world, like we're also looking at how can Hermes and JavaScript/React Native come into the headset. And like there are a lot of like, even though it's a virtual reality kind of an environment, there are a lot of 2D panels that we want to write. And like we've been like talking about using like things like React VR and stuff like that. So there have been a lot of usages, and inside Facebook, we have seen this definitely increase. Even on the outside, I've been talking to a lot of people. I generally hold like kind of office hours where I help people with their performance on React Native applications. And I've seen a lot of people like switch over to Hermes and see gains there. The most recent win that I can think of is the one from the Wix team. The Wix app, which is based out of Israel. Those folks are doing some amazing work in terms of React Native performance, and they just moved to Hermes, and they have seen some really good wins. The Mattermost app, which is prototyped, has had some really good wins. Of course, Microsoft is looking at Hermes, so there's some significant amount of usage there also.
Great.
Very cool.
A question for Neil. Neil, there's a rumor on the internet that you love very long middle names. Can you substantiate that?
I think things like that are better left without comment.
I wonder if you were a QA tester in a former life. Oh yes, a very long middle name indeed. Dar. I'll put a link in the chat for reference.
So normally at this point, I usually ask people like, what are the next steps? Like if people want to try out some of this technology, but it sounds like in this case, things should be fairly straightforward, right? So Hermes, it's basically just you flip a flag right in a config file, more or less. And that's pretty well documented. If you just like, I found it by just Googling like Hermes React. It was quite obviously spelled out. The profiling stuff, it sounds like, is built in as well. Is there any documentation about that? So if people wanted to like refer back to something later on the specific steps, if there are any steps for that, I can drop that in as well. So that people
this might be a good time for Jessie to show the documentation webpage. I think she's done a tremendous job writing, actually not just building the app, but also documenting it. So why don't you bring up the documentation page just to show like the different options and stuff that are available.
Documentation,
yeah,
everyone's
sure.
favorite.
I'll find it now. Yeah, so Saphal and I wrote this documentation on the React Native website that we'll also release. We'll also come with the next release of the CLI. Let me find the.
Yeah, no worries. And I think I found the CLI, the community CLI link that I just threw in the chat as well.
Yeah. Yeah, that's a repo that
Okay.
CLI code that we used earlier. So should I share my screen? Yes. Yeah, this web page is not on the React Native website yet, but when it comes, it will instruct the user with the steps that they can do to profile and then execute the command React Native profile Hermes that I said, and to open the download profile on Chrome DevTools. So record a Hermes sampling profile. So like I did earlier in the demo, we open the developer menu, enable sampling profile, and then like execute some JavaScript in the app, and then disable the sampling profile. So we have like a .cpu profile file in your Android phone's data, and then we execute this command. And what it will do is that it will give the convert the profile using the Hermes profile transformer package that we wrote. And then this has instructions on how to open the profile and just basically load it. Yes, and I think Saphal and I also add some insights about how does the tool that we wrote work. Yeah, so if you want to have more information, then this page is where you can look at it. It will surely come with the next release of the React Native. Yes.
Well, awesome stuff. This is very, very cool. And again, it's really cool to have this work included in the core tool because it's pretty awesome.
Beats my college
yeah,
days for sure.
Yeah. Well, all right. Looks like we're coming up on our time. So one more time, I want to thank Saphal. Thanks, Jessie. Thanks, Neil. Thanks, Ram. This was a lot of fun. I enjoyed learning a lot more about Hermes. I know one thing we like to do, we have 2 plugs we like to end on. Dan, you want to drop yours here real quick?
Yeah, for sure. So we curate the Enterprise React newsletter. Our developer team kind of submits the article. So it's by developers for developers. If it's your cup of tea, Google it.
Yep. And my last plug is if you enjoyed this, if you are a fan of some of these Twitch streams, we at Progress are running an event that we're doing entirely on Twitch called DevReach. So it was an in-person event, but we decided we didn't want to run the typical like online conference. We wanted to mix it up. So totally on Twitch, totally for free. So if you find that interesting, we'll have an entire React day. So I dropped that in the chat as well. If you're interested, check that out. But thanks again, everybody. This is another episode of React Wednesdays. We do this every Wednesday, 1 o'clock US Eastern time. So feel free to hop in. We bring in awesome people from the React world like we did today. So thanks, everybody. Thanks again, Hermes team, for joining us today.
Right on. Thank you so much.